Learn about machine learning question and answers. So basically the question is explain the difference between supervised learning and unsupervised learning. Supervised learning uses the labeled data to train models for predicting outcomes. Obviously everything is predicting outcomes like classification and regression. Classification, we have something like spam detection, or regression is something like housing price prediction kind of thing. Unsupervised learning is it identifies patterns in unlabeled data, such as clustering customer segments using k-means. Okay, uh, so basically, if they ask, what we can say is, in my role at AT&T, I use supervised learning. Okay, for fraud detection models, and unsupervised learning for learning the customer segmentation. Okay, for customer segmentation we have used the unsupervised, whereas for supervised is for fraud detection. Fraud detection models we have used a supervised model. Next, what is overfitting and underfitting? So basically, what is overfitting? Overfitting occurs when a model learns noise in the training data. It tries to reduce generalization. Okay, it tries to reduce generalization. So what we have to do, I mitigate it using techniques like regularization. Okay, regularization, which is like L1 or L2, or dropout in neural networks. Okay, cross validation and data augmentation. So these are the ways how I have tried to reduce it or mitigate it. So reduce dropout and neural network, cross validation and data augmentation. So this is overfitting. It occurs when a model learns noise in the training data. Reduce generalization. Okay, for example, in my churn prediction project I use dropout undi kada, dropout and early stopping to achieve 89% accuracy without overfitting. It asks for only for overfitting, not underfitting. Okay, so that is what it is. Next, how do you handle imbalanced data set? So what you can answer is, I address imbalanced data set using techniques like oversampling. Okay, oversampling. Next is undersampling or class weight adjustment. So these are the three how we can use the handle the imbalanced data set: oversampling, undersampling, or class weight adjustment. In my fraud detection system at AT&T, I applied SMOTE, which is oversampling, to balance fraudulent versus non-fraudulent transaction, reducing false positive by 35%. Okay, so the whole point is reducing false positive. Okay, next one is, what is bias variance trade-off? So what is it basically? The bias variance trade-off balances model complexity. So the whole point is it balances model complexity. High bias, which is the underfitting, results from overly simple models, while high variance, which is like highly bias, is underfitting, while high variance is overfitting. Okay, which is like overfitting, comes from overly complex ones, that is overly simple ones, and there is overly complex ones. So what is the bias variance trade-off? So what we can do is, I aim for optimal balance, obviously, right? That is the whole point. I aim for optimal balance. How is because of, with the help of cross validation and model selection. So with the help of cross validation and model selection, we try to make this optimal balance. In my recommendation system at AT&T, I tuned hyperparameters. The whole point is hyperparameters to reduce variance and improve, to reduce variance and improving accuracy by 23%. Okay, so that's the whole point. Next, what evaluation metrics do you use for classification task? So classification task, what metrics do we use? I use accuracy, I use accuracy and precision and recall and F1 score and AUC ROC. Okay, so for use for classification task, what we use, evaluation metrics, we use all this. What is this? Accuracy, precision, recall, F1 score, AUC, ROC. Okay, depending upon the problem. For my fraud detection system, I prioritized recall to catch more true positives. We try to catch, and used AUC ROC to evaluate overall performance, achieving 35% reduction in false positive. So the whole point is we need to catch true positive and not false positive. So that's it. Okay, next we'll see in another video.